Welcome back to Chemistry Exams Prep. This is Dr. Kulbhushan. We have been talking about the inductive effect and resonance effect. These are two electronic effects that help explain the acidity of organic compounds. So in this question, we need to determine the order of acidity of these following four compounds. In these four structures, compound A and C are substituted phenols. Compound B is an alkanol, cyclohexanol, which is a regular alcohol, and compound D is parahydroxybenzaldehyde. So to answer this type of questions, the first thing that we need to do is to draw their conjugate bases, and then we will have a look on the stability of conjugate bases. More stable the conjugate base, higher the acidity of the corresponding acid. So these four compounds are Bronsted acids because they can give proton in solution when a suitable base is present. So a conjugate base is the species that is formed when a proton is taken off from the acidic group. So here this OH bond is polar, so this bond breaks, the base takes the proton, so the remaining structure is the conjugate base of that acid, and the first one's conjugate base is orthochlorophenoxide ion. The conjugate base of B would be cyclohexanol oxide, and it helps us to draw the lone pairs of electrons because we can show the movement of electrons by resonance. So this conjugate base in case of B is where there is no double bonds there, there is no functional group that can stabilize the negative charge. So this one would be the least stable conjugate base, and that's the reason that compound B would be the least acidic out of these four compounds. The conjugate base of compound C would be metanitro phenoxide ion, and the conjugate base of compound D is this structure, compound D has a very strong electron withdrawing group, CHO group, and compound C also has a very strong electron withdrawing group, nitro group, and compound A has as an electron withdrawing group chlorine. So we know that the nitro is one of the most strongly electron withdrawing group, but in this case nitro group is actually attached at a meta position to the OH group, and therefore the nitro group would not stabilize the conjugate base by resonance. However, it would stabilize the negative charge of the conjugate base by its negative inductive effect. In case of D, this is very strong electron withdrawing group and it is at para position to the OH group. Hence, this would stabilize the conjugate base by negative mesomeric effect and negative inductive effect. In case of A, the Cl gives electrons to the ring by resonance and takes electrons from the ring by inductive effect. So it gives the electrons to the ring by plus mesomeric effect and it takes the electrons from the ring, hence helps stabilize the phenoxide ion, and therefore overall the Cl is taking electrons away as its inductive effect is stronger than its mesomeric effect. So if we compare the stability of conjugate bases, then we observe that the conjugate base in case of D is the most stable because of the minus mesomeric effect of a very strong electron withdrawing group, aldehyde group. Therefore, D is the most acidic compound and C is the second most acidic compound because although nitro group is not stabilizing the negative charge by resonance, but still it helps decrease or disperse the negative charge by its negative inductive effect. And in case of A, the stabilization of negative charge is by a very strong inductive effect of chlorine atom. So the order of acidity is A is more acidic than compound B, which is the regular alcohol, and we know that alcohols are mildly acidic. So to recap the question and the concepts, we have applied the concepts of inductive effect and resonance effect in order to see the stabilities of conjugate bases of these four Bronsted acids. And we know that the more stable the conjugate base, stronger the acid. And hence the order of acidities turned out to be D is more acidic than C and C is more acidic than A and A is more acidic than the B. Alright, thanks for watching.